All right, so yesterday we were doing some work with polynomials where we added them, we subtracted them, we multiplied them. Today we're going to talk about how we divide them. Okay? So we're going to go back to elementary school for just a minute here, and we're going to talk a little bit about how to do long division. And I'm doing this in case you forgot. Because the algorithm or the process that you used to do long division, we're going to use to divide polynomials. Okay? So we need to go review how that process works. So let's start with we're going to start with 480 divided by 13. And let's talk through the process real quick, and then we're going to see how we can apply that same thing to polynomials here, okay? So somebody tell me, what should I do first, or what should I be thinking in my head to get this thing started? I think Jake, you had your hand up first.
How many times 13 goes into 48?
Okay, so I don't jump right into the whole how many times does 13 go into 480. Just look at the first two digits, right? So we think about, because 13 won't go into 4, but 13 will go into 48. How many times? 3 times. Okay? And with a little bit left over, right? You can do it that way, but that's a little more work. But yeah, you can break it into 2 pieces like that. In any event, we know that it goes in 3 but not 4, right? Because 4 would be too big. That'd be bigger than 48. So start with the 3. Now what do I do with that 3? What's the next step in this process?
Don't you take like 13 times 3?
Raise your hand. Tell me. I had 4 people tell me something different all at the same time. Yes, sir?
You do 13 times 3 is 39, so you put 39 under 48.
Mm-hmm.
You do subtraction, and then whatever's left over, you add a 0 at the end.
Okay. So we multiply the 3 by the divisor. Remember, 13 is called the divisor. It's what you're dividing by. So we do 3 times the divisor. That gives us 39. And then we want to figure out how much is left over there. So 48 minus 39 gives us how much? 9. Okay. And then we bring down the 0 because technically we were looking at 480, not just 48. So we've got 90 left over. So then we can repeat the process. Okay, so how many times does 13 go into 90? 48 minus 39 is 9. And then we bring down the zeros. 13 into 90, what was that? 6 times. Yeah, it's 6 times. It's almost 7 times. Right, it'd be 91 if you did it 7 times. All right, so 6 times 13 gives us 78. 90 minus 78 is 12. Okay. So a couple different ways you can write the answer here. Back when you were in 3rd grade, you probably did it where you would just say, the answer is 36 with a remainder of 12, right? Yeah. It goes in 36 times, and there's 12 left over, okay? So you could write it like this then, 36 R12. Now, what you may have done instead is writing it like this, 36 and 12/13. Once you got into fractions in elementary or in middle school, or maybe even elementary school, I don't know. Once you started getting into fractions, it would probably make a little bit more sense to make it like this. You've got 36 with 12/13 added onto it. So like I said, almost 37, right? But we're not quite there. It's 12/13. It's not a full 13/13. So, yeah, question. Oh, you can do the decimal? Okay. So this process relates to what we're doing today as long as we stick with fractions and not decimals. If we were to keep going with a decimal, then the process kind of breaks down compared to what we're doing today. So I'm leaving it in the fraction world here. So, but good question though. All right, so let's try a division problem with a polynomial now. and see what we get. So, and think about what you were doing here, okay? So we're going to do x plus 2 is our divisor now instead of 13. And we're going to take x plus 2. We're going to divide it out of x to the third minus 2x squared plus 4x minus 1. Okay? Haven't done anything yet. Okay? All I'm saying is, instead of it being a number and a number, it's a polynomial and a polynomial. Okay? Nothing, haven't done anything yet, so don't freak out on me just yet. Think about how we started, okay? Up here, we were asking how many times does 13 go into 48?
3.
Okay? And it didn't go evenly. Okay? Now, if we look down here at a polynomial, instead of asking the question like how many times does it go in, think about what do I multiply by to get this other thing. So what do I multiply x by? We just take a look at the first term. What do I multiply x by to get x to the third? Yes. X squared. Okay? So that's where we're starting. I look at the first term of each. What do I need to multiply to this to get that? The answer is x squared. So I'm going to put x squared up on here. It does. We'll talk about that in just a second. Question? All I did was figure out what do I need to multiply x by to get x to the third.
Yeah, but don't you need to do x to the x cubed to get x?
X cubed times x would be x to the fourth.
X has got a little 1 next to it.
So,
You understand that, right?
oh yeah.
No.
That's exactly what we just did. X to the first times x squared. It's x times x times x, because this is x squared and this is x. There's 3 of them. It's x to the third. Right? Okay, that's all we're doing. Okay? Except we're kind of working backwards. We know that we wanted to end up with this. We had this, so we need one of these to make that work. Okay? That's what we're doing here with these 3. Okay? Now, look back up. What did we do? This x squared is kind of like this 3. Right? What did we do with that 3? We multiplied with the divisor, right? We took 3 times 13 and wrote underneath. Okay, well, guess what? We're going to take this x squared. We're going to multiply it by this and write the answer underneath here, just like we did.
It's just x cubed plus 2.
Okay, so x squared times x plus 2. Okay? We have to distribute it. We have to multiply it with the x, and we have to multiply it with the 2. X squared times x, x to the third. X squared times 2 plus 2x squared.
But why would you distribute the x squared to the 2? Because the first time you never did anything with the 2.
That was just so I knew what to get up here to start with. Because I can't have one thing that I multiply by both of these to get both of these. They're going to be different things. So it's just one term to get myself started. How I got this right here, I'm just multiplying like this. X squared times x plus 2, right? And I have to multiply it with each piece of that. So that's where the x to the third plus 2x squared comes from.
Would it be 2x to the third?
No, because it's just 2. It's not 2x.
Oh.
X squared times 2 is 2x squared.
I feel like math is really hard to teach.
What's the next thing that we did after we had the 39? What did we do with that 39? We subtracted it, right? Okay, so the next thing that we're going to do is we're going to subtract what we just got. So I think the easiest way to think about that, just so you're not getting in trouble, I throw a pair of parentheses around it to remind myself that I'm not just subtracting the first term, I'm subtracting that whole thing that I got there. So minus all of this, and then work your way straight down. You can. So this is going to be 0. Yep. And if you did your math right, if you got the right thing right here, this should always cancel itself out. Okay? This one is going to give you something else, though. So,
4x squared.
yes, negative 2x squared minus 2x squared.
But isn't it minus positive?
Yes.
Positive, just minus for the remainder.
Yeah.
So that's just going to be 0, right?
Negative, guys, this is not difficult stuff. Negative 2x squared minus 2x squared is negative 4x squared.
Yeah, that makes sense.
We've done that before. We did it yesterday. Okay, so then we drop down the 4x and drop down the negative 1 because, look up here, what did we do? Drop down the next digit, right? Or the rest of whatever was up here. So we have some more of this polynomial we haven't used yet, so we're bringing that stuff down. And then just like up here, repeating the process. Okay? So we start again. What do I need to multiply by x to get this one now? Negative 4x. What do you need to multiply by x to get negative 4x squared? Negative 4x.
4x.
Oh, yeah. Okay.
Negative 4x times an x is negative 4x squared. Okay? Negative 4x times 2, negative 8x. Okay, so then again, I got to take what I get and I subtract it, right? So I'm going to put it in parentheses so I'm careful and subtract. Okay, be careful. Negative 4x squared minus negative 4x squared. Gone, right? Same thing, subtracting it, gone.
Did you get negative 8 from?
Negative 4x times 2.
You get negative 4x minus 1.
So 4x minus negative 8x. 12x.
I always forget that minus then. Oh, man.
That's why I put parentheses around it to remind myself to use it. So we got 12x minus 1. Okay, so last time, what do you multiply by x to get 12x? 12. Good. 12 times x plus 2. 12 times x is 12x. 12 times 2 is 24. And then we subtract again. Those again should cancel each other out. Negative 1 minus 24. Negative 25. All right, so this is our answer. This is our quotient. And here's the remainder, just like before. So just like we did up there with the 36 R12 or the 36 and 12/13, I can take these results and do the same thing. So there's two ways to write this answer. You could say that it is x squared minus 4x plus 12 remainder negative 25. If you like doing that, that's fine. Or we can turn it into the fraction like we did up there, okay? So we have 12 over 13. Well, where did I get the 12? Where did I get the 13?
Negative 25 over x plus 2.
Yeah. So the 12 is the remainder. The 13 is the divisor. So I'm taking this divided by that. So if we come down here and do the same type of thing, it is this divided by that. Okay, so it's going to be x squared minus 4x plus 12 plus negative 25 over x plus 2. I honestly don't care if you want to write it like this. It's fine. I'm just telling you, your book is going to do it like this. So if you just look at whatever they have right here, that should be your remainder. It's the same thing. That's fine. Okay? Both of these, in my mind, are acceptable ways to write that answer. So, question?
Do you have like a tip or trick that can make it like easier?
What part of it exactly?
Like an entire problem to figure it out.
Nope. Nope. Any other questions?
I plugged that equation in.
You plug the equation into what? Okay. Question?
When you get done, like, how you got 24, you just multiply the 12 by 2 to get everything with the x?
Nope. This whole thing right here is 12 times this. I'm distributing 12 times x, 12x. 12 times 2, 24. Okay, so I'm doing a multiplication kind of in a roundabout way to get each one of these. Okay? All right.
I plugged that equation in. X plus 2 divided
That's because your calculator, you can't use variables because your calculator stores a number into the variable. Well, you probably used an X, right? Yeah. Just type X and hit enter. What does it say? Just type X and then hit enter. So every time you do something with X on your calculator, it's going to use that number for X and then tell you the answer.
Can I make X
Nope.
That'd be so tight.
It would be good if you could, but your calculator has to have a number for X. That's why you can't do this stuff on the calculator.
That would be perfect.
It'd be nice, but you
Someone
can't.
should make that.
They actually already have, but the calculators are like $200.
I'm willing.
I'm willing to buy that.
That's what I heard.
Those calculators are also outlawed on every single standardized test you could ever take.
That is so unfair.
Yeah, well, it would be so unfair to the people without the $200 to buy that calculator, so
Well, it's their fault.
it's their fault.
Good job.
Oh, don't even go there.
People can't afford them.
Okay, let's do another one. We're going to solidify it here, guys. So we're going to take x minus 3 out of x squared plus 8x plus 10, okay? So the polynomial that we're dividing from is a little smaller here, so this one's not going to be quite as long as the last one. But let's see how much you guys remember of the process here. So what's the first thing I need to ask myself to get started? Yeah,
I got a question.
yeah.
This is probably completely irrelevant, but
Mhm.
when in life would we actually use this?
That's not my question to answer.
All right.
All I
Yep.
have to say is he's got to teach it.
It's
Okay, go for it.
X.
What?
X.
Times x, right? The first question you ask yourself is, what times x do you need to get x squared? X. Okay? Shh. So x. And now what do I do with this x after I got it here?
Plug it in, or you times it by the whatever you want on it.
Yeah, you multiply it around like this, right? X times x,
X squared.
x squared, and x times negative 3,
Minus 3X.
minus 3x. And then you take that whole thing that you just got, and you subtract it, right?
No, -5.
So x squared minus x squared, gone.
Oh, that's a
8. Guys, stop just shouting things out. Just stop it. Okay? It's slowing us down. It's making it harder for people to understand what's going on. So just be quiet. Okay? If I call on you, great. 8 minus negative 3. 11x. Bring down the 10. Okay, so now we repeat the process. What do I need to multiply by x to get 11x? Yes? What? 11. Thank you. Plus 11. So now we take the 11 and bring it through. So 11 times x, 11x. 11 times negative 3, negative 33. And now I take this whole thing again and subtract it. 11 minus 11, gone. 10 minus negative 33. Yes. Nope. We're not adding them, we're subtracting them. Yes? 43. Yep. 10 minus negative 33. 10 minus negative 33 is 10 plus 33. That's 43. All right. Okay, so this one, couple different ways we could write the answer again. X plus 11 with a remainder of 43, if you like that, that's fine. Or you can do x plus 11 plus 43 over x minus 3. Okay. Good. Okay.
Does the book usually write it like remainder or?
The book's going to write it like that. Okay? Now, one thing that I had someone ask me about earlier, and that was when we first started this one, they said, when we first got x squared, they asked me, like, does it matter where that x squared goes when you put it on top? And the answer is yes. Can anybody tell me where I knew to put that thing? Yeah. Well, I knew that it had to go first because it's the highest power. Okay? But I knew I had to put it exactly here. Not here, but here. Why? Yeah. Look at this whole column. What do you see in all the numbers here, or all the parts of it here? They're all x squareds. What do you see all through here?
But it's not going to affect your answer to begin with, is it?
No, but it helps keep you organized. Okay? All my x's are in this column. All my constant numbers are in this column. It's just a way to stay organized. Okay? So you always keep it with the same power. Every column is with the same power. So that, and then by the time you're done, when you run out of room, you shouldn't have to have anything after it, right? Because you should already be down to the last possible thing you could have because of the way that it was organized. Yeah?
Can they put a divide in there, like x to the third divided by 2x?
X to the third divided by 2x. No.
Not possible.
Nope, can't do it that way. No.
I was making sure that I was
Nope. Shouldn't run into any fractions that way like that. So, all right, I'm going to have you guys do one more of these on your own just to be sure we're okay before we move on. All right. There's some more coming of some different stuff, but I want to make sure you guys are okay with this before we do anything else. I think so, yeah. Okay. So, take a minute or 5. See if you can do that one all by yourself. Okay, I'm going to freeze it. I'm going to work it all the way out too. And then we'll come back together and see if we got the same thing or not. It's how you know if you know what you're doing or not. It's taking the training wheels off the bicycle. Give it a little push. All right, give you guys another minute or so here.
Really not that hard now that you explain it to us.
You just got to kind of get used to it. Yeah.
I did it wrong.
All right. If you're done, take a look. If you're not done, don't look, but finish and then look. Here's what you should have. Check my work against yours. See if it looks the same or not. 2 different ways to write the answer again, whichever one you prefer.
They're making it was a good example.
It wasn't bad. I got what you were trying to do over there. Okay, so take a look at what I have. Any questions about any of the work that I did here before we move on to the next one? Now's your chance. All right. So here's what we're going to do next. We're going to do one more of these together, okay? Except I'm going to add a little bit to it. I'm going to make it a division problem that looks a little different than what you've seen. But we're going to use the same ideas to do it. It's really no more difficult. There's just some things we got to be careful of, is all. Only reason that I'm doing this is so that you don't get tripped up later. Better to talk about it now than to screw it up later. All right, so the first thing is I'm writing the problem differently, but it is still a division problem, right? So all you need to do is take this thing and put it into the long division looking stuff in the right places, okay? So this is what you're starting with, and this is the divisor. So this is going to go underneath the house, if you will, yes. And this is the divisor, so it's going to be out here. Whichever one comes second's the divisor. Because this is divided by that, right? So that needs to be here.
I just think of it, the first one goes in the house because it gets there first.
You ever heard of Top Dog in the House?
No, Mr. Baby said something about that.
Yeah. If
Big doggy.
Or the big dog goes in the house, the bigger one is in the house. Yeah, you can do that too. Anyway, so that's the first thing though. Okay, we need to know where things go when we put it together. So this is going to go here. Now, this guy, notice that it is 4x to the 4th, and then we're missing a whole bunch, and then plus 5x minus 4, right? There's no x to the 3rd term. There's no x squared term. But remember how we talked about how we have to line everything up in here so that we have everything organized and there's a place for everything? Okay, so to make sure that we still have that, we got to put these little placeholders in there. So we actually need to put some zeros in for the ones we don't have, because otherwise we wouldn't have a place to put the other stuff when we start working it out. So it's actually 4x to the 4th plus 0x to the 3rd plus 0x squared plus 5x minus 4. You'll see in a minute. You'll see in a minute once we start working it out. You need to have a place for x to the 3rd, and you need to have a place for x squared. You got to have them all. Okay? So, start the process. From here on out, it's exactly same thing what we've been doing. Okay? So, what do you multiply x squared by to get 4x to the 4th? 4x squared. Right? So, 4x squared goes in the column where x squared is. If I didn't have this 0x squared here, I'd have nowhere to put it. Right? That's why I need those zeros there. I need a place to put it. So that sets that up for me, okay? So now, same thing like we did before. Take the 4x squared and start multiplying it. Now, I got 3 terms over here. So I got to multiply it by 3 different things and write it all under here, okay? So just go one step at a time. You guys can do it. 4x squared times x squared. 4x to the 4th. 4x squared times negative 3x. I don't know. Anyway, We got to hurry to get through this, okay, guys? So this minus this now. So that's gone. This is positive 12x to the third. You got it. Plus 8x squared. And then we got to bring down the rest of it. 5x minus 4. Okay. Now I got to go again. Okay. So what times x squared gives me 12x to the third? 12x. So plus 12x. And then we got to do a bunch of multiplying again, right? 12x times x squared. 12x to the third. 12x minus 36x squared. 12x times negative 2 minus 24x. Okay, subtract all that business. Should be gone. 8 minus negative 36. 8 plus 36. 44. X squared. 5 minus negative 24. 29. Sorry, I have to go fast. And we got one last time.
44 plus 44.
Plus 44, right? Because we got 44x squared.
Please excuse one more announcement. Fourth hour econ class is selling straight on Hopkins t-shirts for $12. Sales will be until this Thursday. You can purchase a shirt at A and B lunch or from a fourth hour econ student. Thank you.
Okay, so that was just me multiplying by 44. Okay, to get all of that. Okay, and then we're going to subtract one last time. So 29 minus negative 132. I'll help you out. Oh, you already knew it. 161. And then negative 4 minus negative 88. It's plus 84. Don't worry about it. Okay, so 161x plus 84. Believe it or not, that whole thing is your remainder. It's not always just a number. Sometimes your remainder can have x in it with these things. Okay, and that's not wrong. Okay, and we would still write our answer here the same kind of way. Remember, this number up here is the quotient. This is our answer. This is what's like the leftover piece. So we've got 4x squared plus 12x plus 44 with a remainder of 161x plus 84. Okay. I've got one last thing I need to show you guys before we're done. This is the long division stuff. The next thing I'm going to show you is another way to divide, but it's much simpler than this. Now, I'm showing you the long division as well because there are certain problems where you can't get around having to use the long division. You have to use the long division. But there are certain ones of these that you can turn into these things called synthetic divisions that makes the actual work involved go much faster. Okay, so we're going to take a second and do that, and this is going to save you guys a lot of time. I'm going to move it in just a second. Okay, so here's the thing with synthetic division. This only works for certain ones, like I said. So here's for the only one. This is where it works. Only works when the divisor is linear. So remember when we were talking about the different types of polynomials? How do we know when something is linear?
So 4x cubed plus 12x plus 4 squared, that's linear.
No. What's the highest power you can have and be linear?
Infinity.
2 is quadratic. 3 is cubic. 1 is linear, right? No, 1. That doesn't exist. So 1 is linear. So this last division problem that we just did, here's the divisor. Is the divisor linear? Could I have used synthetic division on this one? No. I'm about to show you. Okay, this one right here, here's your divisor. Is the divisor linear?
Yes.
Could I have used synthetic division on this one? Yes. Okay, so we're going to do this problem right here, except we're going to use synthetic division to do it like in about a third of the time. Okay? So here's how it works. If I was given something like x to the third plus 2x squared minus x plus 4, and I wanted to divide it by x plus 1, which is exactly what that problem was that I was just pointing at. Okay, just written out like this. Okay, so what you do is, and the setup looks a little weird, but just like the long division, once you do it a couple of times, it's really easy to follow. Okay, you start by, you look at your divisor. Okay, think about like when we were factoring things or looking for solutions and all of that. If x plus 1 was like the factor, what was the solution that went with that factor? What did you have to do to that plus 1? You change the sign, right? So it's negative 1. Do we remember that?
Wait, I'm sorry, I didn't hear what you said. I was writing it down.
If x plus 1 is a factor, what's the solution that goes with that? The solution is negative 1. If you have a factor that's x plus 1, the solution is negative 1. If you have a factor that's like x minus 5, the solution is 5. Right? So what are you doing to the number you see in the factor to get that? You're just changing the sign. Okay? When you do synthetic division, how you start it is by taking that number. So for this one, I'm going to want a negative 1 to start with. Okay? So there's this little box. Okay? We make a little box and put a negative 1 in the box. And then right next to it, we're going to write all the coefficients off of this thing. So 1, 2, negative 1, and 4. Okay, see how I did that? 1x to the third, 2x squared, negative 1x, 4. Then you skip a line and draw a big bar. Okay, and then here's how we roll with this now. So you take whatever the first number is, that one you just drop down underneath the bar. And then we're going to multiply and write our answer underneath the next one. We take this and multiply with what we have underneath. So negative 1 times 1, negative 1. And then we add down the column. What's 2 plus negative 1? 1. Okay, then multiply again. Negative 1 times 1. Negative 1. Add down the column. Negative 2. Negative 1 times negative 2. Oh my goodness, people. Positive 2, right? Negative 1 times negative 2. It's got to be a positive number. 1 times 2 is 2, so it's 2. All right, add down the column. 6. Okay, so look at those numbers that we have at the bottom now. 1, 1, negative 2, 6. Take a look at your answer that you had right here. What do you notice? 1, 1, negative 2, 6.
Who figured that out? I want to know who figured that out.
The last number that you come up with is the remainder, and the other numbers are all the little coefficients that go on the answer. It's done. Okay? What I do to separate the remainder from the actual like polynomial thing is you just put a little bar right there. So that kind of separates the two things. So this, I know right here, if these are all coefficients, I have 1x squared plus 1x minus 2. That's this. And then I have a remainder of 6. So remainder 6. Done. Okay? Yes? How do I know that the first one is x squared? Good question. Okay. So she asked me, and we're running out of time, so just hold on. This number here, she asked me, how do I know that's x squared? Okay, well, I know that this is the remainder. So if I work this way, constant x squared. If I had another number over here, what would it be? That would be the x cubed number. And you just keep working your way backwards like that. Okay? So that's synthetic division, okay? But keep in mind, it only works for ones where the divisor is linear, okay? Like this. And that's why you can put the little number in the box and go. Okay? Yeah?
How do you know how there's the second column? How did
Yeah.
like the negative 1?
Right here? It's by multiplying. I did this times this equals that. And then I added it down and got this. And then this times this gives that. And then add it down. And then this times this is that. And then add them down. So it's from all these multiplyings.
Okay, so
So it kind of multiplies like this. So this times this is that, this times this is that, this times this is that.
So you knew it started with 1 because the first four bits.
Yeah. Yeah, you always just drop down the first one, and that's the first thing you multiply with to get the next one. And you just keep doing that. Keep doing that. All right, so your homework on this stuff. Sorry to have you go out the door with it, but it happens.
Great. Just great. Doesn't that just make you happy when it starts raining? Oh, yeah.
All right, so I ran out of time. So there is one example on page 176 that I need you to read as well. It's a pretty simple concept, but we didn't have time to talk about it. So read page 176 before you do anything else. Maybe copy down the example off of that too. That'll help. And then you got those to work on, okay?